Okay. So analog signal means variable signal. Okay. Analog signal means variable signal. Means some uh, parameters which are changing. Okay. Changing means increasing or decreasing. So here we are having different parameters like temperature, pressure, flow, level, speed, right? These parameters we are measuring using some sensors. Okay, but when we are measuring this parameter, it is in some format, means it is having some units like temperature, pressure. Temperature is having degree centigrade or Fahrenheit. Pressure is having bars, psi, etc. Speed is having RPM. Okay, so like this, we are having different parameters. So these parameters are measured in terms of non-electrical values. Okay, these are our non-electrical data, but our PLC requires electrical signal. So when to convert this non-electrical to electrical, that we are doing using a transmitter or a transducer. Okay, which is giving you any one of the output here. Okay, two formats are available: voltage or current. Okay, but anyone you can use here, voltage or current. So voltage is for shorter distances, whereas current can be used for longer distances. Okay, because there will be a voltage drop after few meters. Okay, like up to 30 to 40 meters, you can use a voltage signal, right? So after that, there will be a voltage drop. Okay, so to avoid that, we are using current signals for more distances. Here you can see we are having some analog module. Okay, this is for the S7 300 controller. In that we are having this analog module, and in this module we are having some pins like 1 to 20. Here for your one signal, okay, for one channel you are having two wires. Okay, one is plus and minus. So like that we are having channel 0, channel 1, 2, 3, like this up to 7. Total 8 inputs, analog inputs you can connect in one module. Okay, in 300 system. Then you can see there is MR1. Okay, MR stands for measuring range. Here it is like selecting your type of signal, if you are using voltage signal or current signal. Okay, so this one MR is using two channels. Okay, so one channel means one word, that is your one analog input, means it is storing uh, some value. Okay, in your analog channel we are getting some value. So value means one word which is having 16 bits. For 16 bits, if you convert into integer number, you get some value. Okay, that is 240, 241, 243 in that format. That is one analog input. So one MR uses two channels, that is two analog inputs. So this MR is like one jumper. Okay, this is actually one jumper here. At the side of the module, you will see there are some coding A, B, C, D. Okay, on this jumper, you can remove this jumper and you can connect. If you are selecting A, we are having this type of signals like RTD, thermocouple, or direct from thermocouple like 80 or 100 or 1000 millivolts, like that signals you can connect to the module. If you are selecting B as a code, then that is ranging between minus 10 volts to plus 10 volts. If it is C, it's a 4-wire transmitter. D, 2-wire transmitter. The 2-wire transmitter means it is having only two wires, okay, which is connected to your channel, okay, plus and minus. So this transmitter is taking supply from your analog input module itself, and signal is also passing through the same two wires, okay, for shorter distances. Whereas 4-wire, if your module is unable to provide enough supply to the transmitter, we go for the 4-wire transmitters. Okay, so these 4-wire transmitters are having 4 wires, 2 for supply, 2 for signal. Okay, so additional supply we have to give to these 4-wire transmitters. So like that, this 4-wire transmitter, 2-wire transmitter is for current signal. Okay, for current signals, no current transmitters are there. So one MR takes two channels, means if I for MR1, if I selecting voltage for this channel 0 and 1, I can connect only voltage signal. I cannot connect voltage and current here like that. Okay, so here also If I want to connect only current signal, then I have to go for another channel 2 and 3 for current. Okay. For that, I have to select the MR as current option, C or D, 4 bar or 2 bar, whichever you are connecting. For voltage, we have to select B as a port for it. Then this signal, okay, 0 to 10 volts or 4 to 10 milliamps, okay, is going to your A to D converter. So in voltage format, we are having 0 to 10 volts or 4 to 20 milliamps, okay, or minus 10 to plus 10 volts, or in current we are having minus 20 milliamps to 20 milliamps also. So generally in current we are using 4 to 20 milliamps. We are having 0 to 20 milliamps also, but that is not much use, okay, because there will be no signal between 0 to 2 milliamps. It will, your value will be 0. So from 2 to 3 milliamps you will get some value, some output, but again from 3 to 4 you will get 0 as a value. Okay, so from 4 milliamps again your signal will continue without any disturbance. But as you can see, there will be some 3 to 4, again the value is becoming 0. So we cannot understand or identify whether it is due to wire break or there is any interference or any fault, okay, on the instrument. So that's why generally we are using from 4 to 20 milliamps in the industry, okay. So we are not using 0 to 20 milliamps much. In some cases they are using, okay. So this signal is converting, okay, 0 to 10 volts or 4 to 20 milliamps into one word. One word means it is a 16-bit memory, okay. In addressing we have seen, right, 16-bit means one word. So that 16 bits, if you convert into integer number, okay, for each bit we are having some status, okay, some value. So that is converted into some value here for 16-bit. So it is ranging between minus 327682 plus 32767, means minus 32,768 plus 32,767. So minus 2 plus that value will be. So that is what we are getting in our CPU, okay, at that particular channel, okay. So this is for 300. So nowadays for 200 we are not getting this one. It is a input and output address format. For 300, PIW stands for peripheral input word, PQW for peripheral output word. So in our 200 and in this TIA portal, we are using IW as a format only. Okay, IW. IW means input word. We are not using P here. Okay, even for 400 series or 1500 series, we are using only IW as a input format for address. Okay, and then we have to give a byte number. Here you can see 256 and 257. So 2 bytes means one word, right? So it is a word address, okay, for your analog inputs and outputs. So IW for inputs, QW for outputs. So here, for example, if we are measuring 0 to 100 degrees centigrade, some temperature, okay, that we need to convert. It is in degrees centigrade, right? So that we need to convert into electrical format. So this will be 0 to 10 volts. But your signal will not be exactly 10 volts. It might exceed also, right? So like there will be some fluctuation, right? Due to that, it can reach up to like 11.75 volts. Similarly, current, okay, so it will not be exactly 0 to 20 milliamps. It might exceed also. It might go up to like 22 milliamps. So there's like an error, means exceeding the limit. So this is converted to 0 to 27648 in Siemens. Okay, for 0 to 10 volts or 4 to 20 milliamps, we are taking only 0 to 27648. The remaining range is called tolerance. Okay, so they are using this remaining value for tolerance. Okay, 32767 is the maximum value. That's for tolerance, means how much it can bear. Okay, maximum. So that's why Siemens is taking only up to 27648 value here. So this value we are getting in our input channel. Input channel means IW, whatever the byte number it shows. Okay, 80, 64 like that. So on that channel we are getting this value, means this 0 to 100 degrees centigrade is converted to 0 to 27648, which is coming on your channel. But what's the actual value we are measuring is 0 to 100. That means we have to again convert this 0 to 27648 to 0 to 100. That is our engineering units. Okay. So in 1200, it has given separate block called scale block. Okay. But in 300, they are given one number called FC number 105. Okay. That we have to use to convert this 0 to 27648 to 0 to 100 or 0 to whatever the range we set. Okay. Low limit and high limit. Low limit is 0, high limit will be 100. Or you are measuring like 200, 300 degrees centigrade or more than that also you can set. Okay, whatever the range we are measuring. Then this is called unipolar signal. Means 0 to 10 or 4 to 20 milliamp is a unipolar signal. Unipolar means uni means single. That means a single polarity. So it is only a positive signal. But we are having negative signals also. Means the same range 0 to 100 is converted from negative to positive. So this is called bipolar. Bi means two. Okay. So bi means two. Polar. Polar means polarity, negative and positive. So this is again converted between -10 to +10 volts. So you can see the difference. Means 0 to 5 volts we are getting 0 to 50 value here. Whereas in negative to positive we are getting -10 to 0, we are getting 0 to 50 only. That means we are getting nearest value, more accurate or nearest value compared to unipolar signal. Okay. Similarly for current, -20 to +20 volts. So here this value is again converted between -27648 to +27648. That is again converted using a scale block to 0 to 100 engineering units, which we are measuring in PLC in our program. Okay. Then this for scaling. We are having unscale also. That means reverting the same value 0 to 100 to electrical signal, not the raw units, only up to voltage or current signal. At output channel, you will get only voltage or current signals. Okay, that can be used for like a VFD to control the VFD, to control the pressure. Okay, for different values you can control. Okay, using these electrical signals. Now, so this is about the scaling. What we are doing in scaling. Okay, so for unscaling we are using FC106 in 300. That's called unscale convert. But in 1200 we are having a single block only, which you can use for scaling and unscaling both. Okay, but for that they are using a separate concept in 1200 called normalize. Okay, there is a separate block, one more block is provided called normalize. So using that block we have to change the value. Okay, convert the value. That we see the example. Here in the program, if I go to the device configuration, there is your hardware configuration. Here you can see on your analog in your CPU, you're having some two analog inputs. Okay, AI2 inputs. Okay, so it is showing you the analog input addressing input address starting from 64 onwards. 64 means up to how many? 67, 64, 65, 66, 67. These are the byte numbers. So it is having two analog inputs, means two channels only. So one channel means one word. Okay. So for word address, how to give IW64 and another one is IW66. Okay. Similarly, we are having analog output. Okay. So you want to see, you can check in the properties for the analog module below. In general, you go to the CPU, select the CPU, go to general properties. Here you can see AI2 analog inputs. So you can select the range here. Okay. You go down. So for channel 0, okay, and channel 1, there are two channels. For this, the voltage range is already fixed 0 to 10 volts only. Okay. Similarly for the second channel also it is already fixed. Okay. For analog output, also you can see analog outputs here. What output you will get, like voltage or current, whichever you want, that you can select here. Okay. For current will get 0 to 20 milliamps as the output, and for voltage will get -10 to +10 volts, that you can get here. Okay, signal. It is already fixed here with this compact module. Okay. Now I save this for programming. Here, first of all, you go to the conversion operation. Here you can see we are having normex and scalex. So first we have to normalize. That means whatever we are scaling, okay, we are getting integer value, which is your minimum is 0 to maximum is 27648. That's the input we are getting. Okay, as we cannot access I address here, I'm using some word memory like MW 50 I will take. Okay, means consider this as input like IW 50 or 64, whatever it is. Okay, I do one thing, I take MW 64. Okay, because instead of I am using M. Okay, as we are doing with simulator. Then your output will be in real format. Here will get MD some 16. I will get the output. So here what it is doing, it is converting 0 to 27648 to 0.0 in real format, integer to real, that is 0.0 to 1.0. Okay, so for 27648 we'll get 1.0. Okay, then we are scaling this value again from real to real only. MD. Where is mean? This is EN. EN means input enabled. This is MD. Here MW. MW means word address. MD means double word address. I think you have not revised that addressing. I shown you. Okay, bit memory addressing. MW, MD. Okay, so please revise that address. Okay, you can use the bits into byte, word, and double word address. Okay, so here you can use this MD60 as an input here for scale block. Then here will get some range. What is the minimum value you want to convert? 0 to 100. That is 0.0 to 100.0. This range you will get in the MD some 64 or 64. Okay, so MD. Yeah, 70. Okay, so MD70 will get the converted value. So I save this and start your simulator. here and go online. Now for input, your value should be between 0 to 27648. So I select here, right click, modify operand. So some value like I give 10,000. For 10,000, what I'm getting 0.36. Okay, this 0.36 is again converted to between 0.0 to 100.0. So you get it is multiplied by 100 here. You are getting 36.16 some value here. Okay, so if I again change this up to 27648, maximum value 27648. It's 1.0. For 1.0 you are getting 100.0. Okay, so here we are normalizing our 0 to 27648 between 0.0 to 1.0 only. Okay, it will not exceed this value 1.0. Okay, so that 0 to 0.0 to 1.0 we are converting to 0.0 to 100.0. So that result is coming in your output here. Okay, similarly we have to do unscale. I'll just copy, Control C, Control V. The same value input MD70 I'm using, which is your real input. Okay, this real input I'm using here. For this, you have to convert to 0 to 100.0. You are getting, and MD some 80. This MD80 I'm taking here as input, which we have to convert into integer. So your integer range should be like 0 to 2 0 to 27648, and your output will be like output address QW 80. We're having the address there, that will be converted. So edit, download. So this will be directly going to your output module. Okay, after the conversion, the result will go to the output module directly. Here you can see what is the input here, 27648. At output you can see it is showing 27648. So whatever the input has changed here, like 500 something. Okay, the same output will get. Okay, so at output this value is 0 to 27648 is again converted to 0 to 10 volts or 4 to 20 milliamps. Okay, so this is what we are doing in scaling.